Let's find the derivative of the following functions with respect to x. Now for number 4, before we differentiate this, we will have to write this first in exponential form so we can use the power rule. Now, if you recall, if you have radical expressions, you can write it in exponential form using the formula here. The nth root of x to the m is equal to x to the m over n. So that means this square root of x here will be written as, so copy 5 first, x to the 1/2. So if you don't see anything here, if you don't see anything on the index, that means the index is 2. And the exponent here, if you don't see anything, is 1. So therefore, square root of x is x to the 1/2. Similarly, for cube root of y, to copy 2 first, and then for the cube root of y, you have y to the, now the power inside is 1 because you don't see anything. So 1 is the numerator divided by the denominator is the index. See, the denominator here is the index divided by 3 plus 1. So now that we have written this in exponential form, you can now use the power rule formula. The general power rule formula is the derivative of u to the n with respect to x. So let's put a constant. The derivative of c u to the n with respect to x is cn, so c times n, u to the n minus 1 times the derivative of u with respect to x, so times du dx. Now let's apply that here. We differentiate both sides with respect to x. So we have 5 times 1/2, so 5 times 1/2, x to the 1/2 minus 1. 1/2 minus 1. That is equal to negative 1/2. And then it's equal to, so this is equal to negative 1/2. 1/2 minus 1 is negative 1/2. And that is equal to 2 times, you bring down 1/3. So 2 times 1/3 times y to the 1/3 minus 1. And 1/3 minus 1 is equal to negative 2/3. So negative 2/3. Now, since we're differentiating it with respect to x and we have a y here, that means we will multiply it by the derivative of y with respect to x. So we just use chain rule here. Again, cn u to the n minus 1 times du dx. That's why you have dy dx here. Plus, the derivative of 1 is 0. Then you go ahead and compute or solve for dy dx. Now, before we solve for the dy dx here, let us first remove the negative exponent here. That means if you remember, if you have a negative exponent, so x to the negative n, that is just equal to 1 over x to the n. So we will apply that here. We have, again, 5 times 1/2 will be 5 over 2. So 5 over 2 times, this one here becomes 1 over the square root of x. Square root of x, because you have a negative exponent. To make it positive, you put it in the denominator. So essentially, you have x to the 1/2, but x to the 1/2 is equal to square root of x using this formula here. It's equal to 2/3, so 2 times 1/3 is 2/3. And then this y to the negative 2/3 becomes 1 over y to the 2/3, and that is cube root of y squared times dy dx. Then we can rewrite it or write this as 5 over 2 square root of x is equal to 2 over 3 cube root of y squared times dy dx. Now to solve for dy dx, you just multiply both sides of the equation here by the reciprocal of this coefficient here. So multiplying both sides of the equation by the reciprocal here, you get dy dx on the right hand side. So I'll write that first. And then you have 5 over 2 square root of x times the reciprocal of the expression here. And that is 3 times cube root of y squared divided by 2. So now for your homework, you may choose to write your answer like this, or you can simplify it a little further. My Math Lab will accept if you input your answer this way. So this one, if you simplify a little bit further, you have 15 cube root of y squared divided by 4 square root of x. Number 5, find dy dx in this equation here using implicit differentiation. So we begin by differentiating both sides of the equation. We have 2 times the derivative with respect to x of ln y equal to the derivative with respect to x of quantity 7 x to the 6 plus 5. Now, for the derivative of ln y, we will use chain rule since y here do not agree with the variable here. So we use chain rule. If you remember, the derivative of ln u with respect to x is equal to 1 over u times the derivative of u with respect to x. So that means for ln y, we have 2 times 1 over y times the derivative of y with respect to x is equal to, now the derivative here is 42 x to the 5th, you subtract 1 from 6, so you have x to the 5th. And the derivative of 5 is 0. Okay, so you don't put dx here because x agrees with the variable here. So therefore, to solve for dy dx, you just need to cancel this expression here. That expression is 2 over y. So that means you're just going to multiply both sides by the reciprocal of 2 over y. That means you multiply both sides here by y over 2. And you do the same thing here. Therefore, dy dx is equal to 42 x to the 5th y divided by 2. That you can simplify this. 42 divided by 2 is 21. So 21 x to the 5th y. That's your dy dx. Now for this last example here, to find dy dx, we will use implicit differentiation. And we begin by differentiating both sides of the equation with respect to x. Now when we differentiate this with respect to x, we will use product rule since this is one expression and this is another expression, and they're being multiplied together. So again, you have a variable here in terms of x, and this one here, the variable here is y. So using the product rule, we have x squared times the derivative with respect to x of e to the y, plus you copy e to the y times the derivative with respect to x of x squared is equal to the derivative with respect to x of ln 3x cubed minus 1. So copy x squared. Now the derivative of e to the y is equal to e to the y. And then since you have y here and x here, so you use chain rule. So times dy dx. Plus, copy e to the y. Now the derivative of x squared, now x here agrees with the variable here x. The derivative of x squared is just 2x. And that is equal to, now differentiate this. Again, the variable here is x, and we also have x here. Therefore, we just use the formula. The derivative here is 1 over u. So again, you use chain rule still. So you have 3x cubed minus 1 times the derivative of 3x cubed minus 1. So the derivative of 3x cubed is 9x squared minus the derivative of 1, which is 0. So next step is to transpose this on the other side of the equation so we can solve for dy dx. So we try to isolate the expressions in terms of dy dx. So this expression here becomes x squared y squared. Copy dy dx. That is equal to, now this one is 9x squared divided by 3x squared minus 1. And then this will be transposed on the other side. That is minus 2x e to the y. Now as our final answer, dy dx is equal to, now we don't simplify it. It's okay. You can input your answer like this in MyMathLab. So you have your numerator is 9x squared divided by 3x squared minus 1 minus 2x e to the y all over the expression here, x squared over e to the y. Now the derivative dy dx is equal to the expression here. Now you can proceed and simplify this, or you can also just stop here and input your answer like this. MyMathLab will accept it.